Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haikal bin Halim. We are from the group 5. Want to present topic about a good practice guide to energy monitoring and targeting. We have summarized the topic to simple discussion for our group to easy understanding the topic about energy monitoring and targeting. This is our project from the subject energy efficiency, and the lecture is Farida Hanim binti Muhammad Noh. Okay, we go to uh, group members. Our group members have three members. First, we have Muhammad Farid bin Nazri. The matric number is CN190263, and me as a leader of Group 5, Muhammad Aikal bin Halim, CN190264, and the last one is Putri Nazatul Iman binti Abdul Saad, CN190263. Okay, this is the table content of our group. We have 6 parts that we have divided into 3 parts. First, Putri Nazatul Iman will presentation about introduction of topic and what is monitoring and targeting. Then we have Farid Nazri. We present about why monitoring and targeting and how to conduct monitoring and targeting. Me will present about discussion about whole of the topic and make a conclusion from this topic. Okay, we will start the first slide with Putri Nazatul Iman will uh, presentation about their slide. Okay, we start with Putri Nazatul.
Introduction. The old adage, you can't manage what you don't measure, is particularly apt for energy management. Effective energy management starts with measuring how much energy is being consumed and where is it being consumed. Energy consumption data must be collected and analyzed to understand the potential for energy performance improvement. Targets for energy consumption can then be set and actual energy consumption can be measured against the target. What is monitoring and targeting? Energy monitoring and targeting is a technique for managing energy that uses energy consumption data and other data as a basis to eliminate waste, reduce and control energy consumption, and improve operating practice. Monitoring and targeting. The first one is measurement and verification of savings from capital investment activities. Furthermore, improve product costing. In addition, waste avoidance, not just energy, also water and materials. Then, ability to benchmark against competitors and sister company. Last but not least, improve data for justifying capital investment. How to conduct monitoring and targeting. Data collection. Energy consumption data should be collected for all significant energy sources at site level: electricity, thermal fuel, transport fuels. Data should also be collected for the significant energy consumer on site, for example boiler, furnace, steam generator, dryer, and major processor. Data should include energy consumption and data on the relevant variables that may drive energy consumption up or down. This can be an effective way of monitoring energy consumption for specific equipment: boiler, refrigeration equipment, CHP plant. Energy output is compared with energy input to give a conversion efficiency ratio, which is then compared to previous performance, design efficiency, or both. If boiler efficiency or chiller coefficient of performance is changing, then this can be investigated to identify whether it is due to a problem with the process or system or whether it is due to a change in the load on the system. Appropriate action then can be taken.
Hello, nama saya Muhammad Farid bin Nazri. Hari ini saya nak terangkan pasal control check. Okay, kalau control chart based on report, dia adalah macam report ratio yang between dengan actual consumption and budget target atau baseline. Dia deviates above the upper limit. This indicate abnormal event and should provoke an investigation. It's predicted by the baseline and can be used to track of energy. So basically kalau contoh kita tengok daripada baseline ni, kita boleh tengok daripada contohlah kan ni setahun. Lepas tu tengok actual consumption baseline ni macam ni baseline dia kilowatt. Ini upper control limit. Ni warna hijau ni control limit dia lah. Lepas tu ni dia punya lower control limit. Ni variance ni penggunaan bulan tu. Okey, contoh kalau kita tengok dekat Januari, Februari, semua still under upper control limit dia. Sampai ke March ni, sehingga ke Mei 16 ni, tiba-tiba naik penjolakan tinggi. Okey, dari situ kita kena tengok dia punya, kiranya kita kena investigate lah kenapa benda ni berlaku tiba-tiba. So supaya kiranya kita dapat identify apa cause this performance tiba-tiba naik meninggi, energy consumption meninggi naik lah. Okay, ini kusum charting. Kusum charting ni macam dia adalah cumulative surf control chart illustrating energy performance of consuming system, steam system atau kill-in, monitor and compare. Okay. Ini contoh dia punya kusum chart. Okay, based on kita tengok ni kan, output tanaman dia punya output production, baseline energy consumption, dia punya energy baseline lah, actual consumption dia punya penggunaan yang sepatutnya. Okay. Yang kita tahu kusum adalah teknik yang bagus, method yang kita boleh untuk macam indicates difference between the actual consumption dengan baseline energy consumption. Okay, kita boleh compare dengan menggunakan graf ni untuk dalam masa setahun tu. So kita boleh tengok apa perbezaan yang kita boleh nampak. Okay, kusum arc furnace example detect significant event affecting energy performance different between the actual consumption and the baseline will be small and readily positive or negative. Kusum will trend towards zero over time. Kiranya yang kita tahu dia boleh detect energy yang effect kepada performance. Lepas tu the difference between the actual consumption ni dengan baseline randomly dia akan towards positive or negative. Most of the time dia akan ke kosong lah kan. Okay, as we see in the performance graph ni, benda ni jadi semakin teruk. Dan during baseline baseline November 2016 sampai December, the occur tend to reverse. Kiranya dia akan worse again, tapi effect dia akan trending naik ke atas pula. Daripada sini kita tengok sini. Okay, planning and energy consumption. Okay, ada 4, iaitu monetary frequency, targeting, reporting and revising energy performance indicator. Okay, saya part 1 ni, yang selebihnya kawan saya Haikal akan terangkan. Okay, monitoring frequency. Monitoring frequency ni dia lebih senang untuk kita identify cause of waste. Lepas tu the level of variation should taken into account. Load that vary regularly should be monitored more than frequently than loads that generally remains predicted over a long period of time. Energy consumer that cost most to run should be monitored more frequently than smaller consumer. Okay, yang kita tahu untuk monitoring frequency ni, dia macam identify the cost yang may dissipate the data kiranya aggregate for over longer period. The energy consumer cost more to run should be monitor frequently lah, yang mana energy yang melibatkan penggunaan energy yang tinggi tu kita kena monitor selalu. So kita dapat predict over a long period of time and typically recommend motor significant energy use, kurangkan penggunaan tu dan prevent daripada penggunaan energi yang terlebih tinggi untuk jangka masa akan datang. Okey, itu saja, sekian daripada saya. Terima kasih.
Okay, targeting. Energy consumption is being monitored effectively. The information collected should be used to set target. Target can be set based on the first thermodynamic minimum plus a percentage to allow for imperfect process and for the percentage reading. Then we can manufacture recommendation, a benchmark again companies carry out similar activities, and the last one is a percentage improvement versus the previous. Shift, day, week, month, year is a talking relevant variable into account. Okay, reporting. For reporting, indicate clearly to the audience whether or not they need to take action. Different audience require different information at different frequencies. The operator of a large energy consumption should be aware of energy performance indicator in real time. That will help us to focus attention on the area that need action, then avoid a problem or opportunity getting lost in noise of too many reports. That is the function of the reporting. Then we go to reporting format. Reporting format have 5 part of reporting. First, we have absolute consumption. Second, we have actual consumption versus budget, target, or baseline. Number 3 is a control chart. Then we have heat maps. Then the last one is overspend leaks table with traffic light. Okay, we go to the absolute consumption. This is example graph for absolute consumption. This is the most basic format for energy performance reporting in a graph, absolute energy consumption versus the time. A more sophisticated format is annually graph of energy consumption, which can effectively highly in energy consumption. Okay. We go to the next format, reporting. This is actual consumption versus budget, target, and baseline. The difference between actual consumption and budget, target, baseline can be recorded and shown graphically. It can be reported as a ratio between actual consumption and budget, target, baseline. The difference between actual and expected consumption can be also be effectively highlighted using a consume chart or cumulative control chart. Okay, this is actual consumption or expected consumption graph. For example, okay, we go to the next as control chart. Okay. Is reported as a ratio budget target baseline deviated above the upper limit. This indicates abnormal event and should provoke and investigate. It predict by the baseline can be used to track or energy performance. That is the function of control chart. Okay, for the figure in this slide, this is a control chart example. Actual consumption minus baseline consumption kilowatt per hour. Okay, we go to next slide. It's about overspend leak table light traffic light. Overspend leak table with traffic light. First, uh, this is a technique when the energy consumer and other of overspend so that the plant that is costing the most versus its budget. Useful for senior management with variants that are outside the normal control limit are highlighted in red or green for priority investigation. Okay, the last one is about heat map. Heat map. The color code energy consumption heat map. The magnitude of the energy consumption can be color coded so red indicated is high vary consumption, cost vary versus the baseline. Blue indicate low energy consumption or cost versus the baseline. That is the function of the heat map for energy consumption, that we can know the red indicate high energy consumption and the blue indicate low energy consumption. Okay, we go to the revising energy performance indicator. We can know energy performance indicator are not set in stone. They should change when applied. For example, if the energy source for site or a process change, this will require a new indicator. Second, the process that the significant energy user may not continue to be significant energy user and hence may no longer need their energy performance indicator monitor. Other process that will not significant energy user last year may become significant energy user this year. Okay, the next is the process change may require the relationship between energy consumption and the relevant variable to be raised and a new baseline to be developed. If a major upgrade is made to a process, then initial of consumption should be measured against the existing baseline to verify saving. When saving have been verified over a given time period, it usually makes sense to develop a baseline using energy consumption and relevant variable data for the period following the upgrade. And the last one is about energy performance indicator should be re-examined annually if they have not been revised for other reasons within India. For example, if the baseline is set in 2014 and the indicator show an improvement of 10% in 2016 versus the baseline is may interrupted as progress. However, if the indicator show a 15 improvement in 2015 versus the 2014 baseline, the 2016 is actually a worse performance than 2014. This confusion, this confusion can be avoided by revising baseline annually. We go to the conclusion of about a guide to energy monitoring and targeting. Uh, this subject will be the energy monitoring and targeting will be delivered to substantial energy saving. Then it also acts as yearly warning system that can improve quality, reliability, reliability, and health and safety. Furthermore, monitor energy monitoring and targeting also will be able to minimize environmental effect and minimize energy costs of waste without affecting production quality. This for our group uh, presentation. I hope lecture will be checked our slide, and thank you.